Greetings, the Austereo 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Today, we're doing another experimentation video. Now, this circuit here is a discrete preamp, which is designed for that 5-watt quasi-complimentary power amplifier, which is linked in the description, that I've already made a PCB for in a previous video. This is part of that. This goes with it. This is the Austereo control amplifier, and that's project number 44, because the power amp itself is project number 46, and there it is there. So this comes from the Elektor magazine from July-August 1975. I'm not going to explain too much about the circuit because, well, the description's already there. That sort of like tells you how it works to a point. I mean, it's not very descriptive, but anyway. So basically, we have a 50 millivolt input signal, and that's going to be RMS, coming in through this blocking capacitor into this Class A preamplifier stage, consisting of these two transistors. This is going to be the voltage amplifier. This is a high gain, high impedance at the input and low impedance at the output preamplifier. The gain can be adjusted by this trim pot down here to give us the 2 volt RMS output at the selected input voltage. This capacitor is basically going across this 1K emitter resistor on the first transistor here, which is going to be controlling its overall gain, because this pot does actually go between, well, the capacitor and ground. So that gives us a variance of gain there for the input stage. The output is then fed into this 100 microfarad capacitor, which is a bit large. It doesn't really need to be that large. Going into the volume control, which then goes into a band axle circuit featuring a treble and bass control. And then that has this transistor T3 here, which is part of the band axle circuit. So this is now actually an active band axle circuit using this transistor. It's basically the same as using an op-amp in the inverting configuration inside the band axle circuit in the feedback path there. So it controls the gain at certain frequencies, and this transistor is doing the same job. And the gain is controlled with this emitter resistor and bypass capacitor, which is 50 microfarad. So we're talking 1975 here. So it'd be more like 470 microfarad now. And that will control the output transistor's overall gain. This 1 nanofarad capacitor between the collector and ground is, according to the text, to prevent this transistor here from oscillating. That's then going through this 25 microfarad, which is still a bit high, capacitor here to the output with a 100k impedance resistor here on the output, giving us our 2 volt RMS output. Over here is the balance control circuitry. See, we've got a 470 ohm here, 470 ohm here between two ends of the pot. And the wiper is going to ground. And we've got point A, which connects to point A over here. So that is supposed to control the balance of both channels if this was, in stereo configuration, because this is only showing one channel, not both. But that's how that would be wired. How well that's going to work in practice, well, we're going to have to test it. So without further ado, let's get this circuit built up on Breadboard and actually begin testing it and see if this actually works. Because if it does, well, I might be able to do something with it. I love Breadboard experimentation. The circuit is built, and I did most of this off camera of building it, test it in stages, just to make sure that it all works, and I haven't forgotten to connect something, which I tend to do quite often. So I didn't want to waste time on camera trying to fault find things. So the circuit is currently powered up, and as we can see, we've got an output. Now we're coming directly out the output after the tone control network. We've got the volume control set to maximum, and we're getting 2 volt RMS out as it says on the schematic, and I'm putting 250 millivolt roughly in RMS. Now I've got a 500 ohm trim pot there instead of a 1K because I don't have one, but it still seems to work. But what I want to test first is the original circuit said it had an input sensitivity of 50 millivolt for 2 volt RMS out. So what I want to do is I want to adjust my oscillator to 50 millivolts and then adjust that trim pot to see if we can get you know, the same 2 volt RMS out. So first I will increase this one so we can see what's going on. So the top trace, by the way, is the output, the bottom trace is the input. So I'll drop this down, down, like coals, down. Oop, too far. Right. Come on. Come on. Ooh, that's close enough. So now I'll take a screwdriver and I will adjust the trim pot and it looks like, yes, we can. There we go, almost 2 volt RMS. So that part of the circuit is working perfectly. However, I don't really want it for this test at 50 millivolts, so I'm going to put it back up to 250, and as we can see the output's distorting. So 200 and, come on, where's the sweet spot? Close enough. Drop that back down, and now I will decrease the trim pot until we get 2 volt RMS back out. Because I didn't actually test this yesterday when I built it, but as we can see, the gain is reducing and there is quite a fair bit of adjustment there, so that's pretty good. And we're almost at 2 volt, and there it is there. Excellent. So the next thing I want to test is the balance pot, which goes in the same circuit area as that via a 470 ohm resistor, which I don't actually have the pot connected at the moment, but I'll do that and we'll come back. Okay, so I've got a 100k linear pot cobbled into the circuit instead of going to ground, and the red lead going off to the end of the 470 ohm resistor. The pot's set in the center. The circuit calls for a 10k, but it doesn't really make that much difference. Okay, so if I rotate the pot fully clockwise, which should be muting this channel, it doesn't actually do anything except increase the gain. Okay, so that part of the circuit does not work. I've already tested this off camera with a 10k pot, which I found on another circuit board, and it does the same thing. So it's not the value of the pot, it's the circuit does not work. It may have worked in 1975, but it doesn't work now. So I suppose the easier solution is to take this and put this at the output of the volume control, which is over here next to the input of the back handle. Okay, and probably should have a series 1k resistor there, but I don't, but for now this is fine. I'll rotate the pot fully clockwise. The signal buggers off, although it's doing weird stuff. Yeah, okay. So I might try moving that to the input of the volume control, which is there. No, it's doing the same thing. So I might have to experiment with that off camera to actually get that to function correctly, because it's not. I could always delete on the balance pot. It's not really a control that's used much these days anyway. Next thing I want to do is I want to test the operation of the backstandle circuit, or band axle circuit. So I'm going to change my mode to square. Now both the treble and the balance pots are in the center positions. So if I play with the treble pot, that's full treble, so that's doing something. That's no treble, so that's doing something. Back to center. Play with the bass pot. That's full bass. That's no bass. So those pots are doing something. Excellent. So I'm going to go back to sine wave. We'll also notice that the input and output are out of phase with each other. Now that's because the band axial circuit being active using that NPN transistor is inverting the signal. Pretty much the same way if you use an op-amp active band axial circuit in the inverting configuration as is customary, you'll get an inverted output. So if I move my oscilloscope probe to before the volume control, and it's not triggering because the trigger is on the yellow trace, as we can see, both signals are in phase with each other. So there we go. This little preamp circuit is working apart from the balance control issue. Well, I actually did manage to fix the balance pot. So I played with that a little bit off camera there for a few minutes, and now it doesn't do what it was doing before, but it does attenuate the signal without making it clip weird. And all I did was put a 1K resistor in series with the output from the volume control before the input of the back handle, band axial. The balance pot comes off at the input of the back band axial circuit, but this is now in series between the balance pot and the volume control is what I'm trying to say, which is actually the customary way to do it, and that's really what the importance of that 1K resistor is. So there we go, that's fixed that problem. All I had to do after that was just increase the gain pot a little because we lost a little bit of voltage because of the 1K resistor. So I guess the next thing for this is to hook it up to the 5-watt power amplifier and actually hear how the thing performs. So that's going to be my next task, is setting all that up. And by the way, I forgot to mention that the power supply is set to 24 volts, which is what the power amp runs off of. We're currently drawing 14 mA, but that's going to be more like 4 mA because there's an LED in circuit which is drawing 10 mA. If I actually remove the LED, see, 4 mA. So the circuit is pretty, even when it's actually outputting at full power, the circuit's not drawing that much current. So I'm just going to plug that LED in because I like having a little indication there. There we go. Alright, I've got the preamp cobbled into the power amplifier that goes with it. It is turned on. We're drawing about 35 mA now, take 10 from the LED, so only 15 mA, which is okay, that's pretty good. The oscillator is off, but I can still hear that 1 kilohertz signal in the background, which seems to be coming off the power supply for whatever reason. But I'll turn the oscillator on, and we can hear there is a signal trying to get out. And there's some volume. Balance sort of does something. Treble is doing something. And bass is doing something. Right, I'll kill that because that's annoying. So, I did notice one thing on the oscilloscope though. I'm going to change this to like 200 Hertz. And yeah, the bass is doing something. Now I did notice something on the oscilloscope when you first power this circuit up. It takes a little bit for it to stabilize and produce the output correctly, but I guess that's alright. So now I'm going to hook this up to a proper audio source, some music, and we're going to actually hear what the whole entire circuit does. Okay, I think I'm ready to go on this now. So I'm going to play a track which is a bit of reggae instead of, you know, emotional mess for a change. I need something with more bass in it. Yeah, the bass pot seems a bit supple. Well, I found the problem. That's better. I had the center wiper and one of the ends connected to the same point in the circuit. That's why it wasn't working. I still think 47 nanofarad a bit high actually. It's a bit too much bass response. Yes, anyway, it works. I'm not sure I'm liking the way that balance pot is working. It doesn't seem to function as it should. However, the preamp itself, apart from picking up circuit noise because of the layout, there's no loud hiss coming out the speaker, because even where the volume pot is situated in the circuit, it's before the power amp. Unlike that 10 watt per channel amplifier I built before using a discrete preamp, it was noisy as hell. So I ended up having to put the balance pot at the volume control and balance pot at the output of the circuit rather than at the input, just to control the noise floor. But now this circuit is working and performing perfectly. I don't see any needs to modify it any further. I may have to play around with some values off camera and work out the balance pop a little bit better than it is now. However, this is pretty much where I'm going to leave this video. We see that the circuit works. It just doesn't work in its original configuration of where the balance pot was. I don't know why. I do have everything wired correctly. There is no reason why it shouldn't operate. So yeah. Anyway, I'm going to leave this video here. The next thing for this, I guess, is routing a PCB. And when I say that, I mean routing a PCB with the preamp and the power amps and power supply all on the same circuit board, so it's a complete stereo amplifier unit, which may be a fun project for someone to build later. I can do that. It's going to take a little bit of work of routing it correctly on a circuit board in the CAD program, but when I get the time, I'll do it. And if anyone's actually interested as well, I mean, that's the thing. If you're not interested in a circuit board for this, well, then I won't bother. But I kind of starting to like this circuitry from 1975. It's kind of growing on me, so there is that. Yeah, so leave me your thoughts down below. But anyway, I'm going to leave this video here. As always, this is the Austereo saying, see ya, thank you for watching. And if you haven't done so already, please go down below, like, comment and subscribe. And I will see you in the next video. I'm not sure what that's going to be yet, but we'll soon find out. Thank you for watching. See you later.